Hey everybody, I wanted to get you ready for the exam coming up, and this is just a sample problem from Brown 15.26, and this is showing how to manipulate the equilibrium expression or the equilibrium constant based on how the reaction is changed and how it's written. Okay, so here we go. So this is, I'm going to do sample problem 15.6, which is this guy right here. Okay, and then we will go there. So that now, for this reaction, we're given a Kp. Okay, what we need to realize is that as we change the reaction, the Kp is going to change. Okay, but as long as the reactions are related to each other by basic manipulations, all we have to do is manipulate the equilibrium constant in order to get the right answer. So for something like this, what is the relationship between this given reaction here and then what we're trying to find here? Okay, in part A. Okay, in order to do this, my trick is really to just pick one product or one reactant and see what happens to it. So my eyes are just really focused right here on this guy. Okay, we have 4 HCl. Here we have 4 HCl. So what happens to this? Well, to go from here to here, what happens is this reaction is just switched around. These reactants, these products here, eventually become the reactants, and these reactants become the products. And I do that really just by looking at what is going on with the one thing. So I look here, and then I look here, I'm like, oh, it switched sides. So when that happens, well, let's look at what happens to the equilibrium constant. Whoa, hey, oh, whoa. Okay. So what happens to the equilibrium constant is you have Kp is equal to products over the reactants. And so if those things switch, if the reactants become the products and the products become the reactants, if you see the relationship between them, then all you have to do is take the reciprocal. So by switching the reactants and the products, by flipping them around here, all you have to do is take the reciprocal of the Kp. So if Kp is equal to 0.0752, so Kp is equal to 0.0752, okay, well, now all we have to do to find for part A, for 26 part A, all we have to do is 1 over 0.0752. So 1 divided by 0.0752, and so the new Kp for that is equal to 13.29. Okay, so that was 13.30. Now for part B here, again, I'm just going to focus on one of the reactants. Here's 4 HCl. Now here's 2 HCl. So it stays on the same side, but we react, but now that it's by half. So this is just half of this reaction up here. Well, when we multiply a reaction by a power, what ends up happening here for part B is that changes our coefficients, which change the powers that we raise it to. So in the end, all we have to do is multiply by the factor that we multiplied the reaction to. I'm sorry, we don't multiply, we raise the reaction to the power that we just multiplied the reaction by. So let me show you. So our original Kp was 0.0752. Okay, so now all we have to do is raise it to the half power, or take the square root of it in order to get the right answer. This is half of this reaction, so we're going to raise the Kp to half, to the power of half. Okay, so 0.0752 raised to the power of 0.5. Okay, that equals 0.274. Now, just so you can believe the math here, we can also do the square root of 0.0752. And when we do that, it's the same answer. The half power, that means the square root of that. Okay, so now question C kind of combines concepts here between the couple of problems that we already did. And so it says, what's the value of Kc for the reaction in part B? Okay, well, that's cool because we know the relationship here between Kp and Kc. And that relationship is Kp equals Kc RT delta N. This is for part C. Okay, well, R is a constant, 0.0821 liter atmosphere per mole Kelvin. Okay, T, that's got to be given somewhere. Look, 480 degrees Celsius. So T equals 480 degrees Celsius. And then delta N is equal to moles of product minus mole reactant. Okay, so now we add up, we go to part B here, and so we go, okay, well, how many moles of reactants are there? That's 1 and 1, and this is 2 and, so this is 2 and 2.5, right? So 2 moles, 2.5 moles. So moles of product, this was 2.5 minus 2, so delta N equals 1/2. And so now we can do our problem. Now Kp equals Kc. What was it that we were given in the problem? Kp. So this is Kp now is 0.274 equals Kc, which we're trying to find, times R, 0.0821, times T. T is in Celsius. We need to convert it to Kelvin. So to do that, we have to remember our beginning chem. So we have to add 273. So 480 plus 273. So that's in Kelvin is 753. So this is going to be times 753. I'll keep the colors there because that way you know where that temperature came from. And this is to the half power. Okay, so we do 0.0821 times 753. And then we'll do the square root of that. And then we'll do 0.274 divided by that. And so we get Kc equals 0.0348. Okay, so that combines a lot of things. So manipulating Kp and Kc and being able to interconvert them, definitely a skill that I think that you should keep in mind.